Minkowski space, also known as Minkowski spacetime, is a mathematical framework developed by the mathematician Hermann Minkowski in 1907. It provides a way to describe the geometry of spacetime in special relativity, combining 3 dimensions of space and 1 dimension of time into a 4-dimensional continuum. In Minkowski space, an event is described by 4 coordinates, 3 spatial coordinates x, y, z, and 1 temporal coordinate where c is the speed of light. The use of the speed of light is necessary to account for the fact that time and space are fundamentally interconnected in relativity. The geometry of Minkowski space differs from the Euclidean geometry commonly used in everyday life. Instead of the Pythagorean theorem, which describes distances in Euclidean space, Minkowski space uses a metric called the Minkowski metric or spacetime interval. It is defined as ds squared equals c squared asterisk dt squared dx squared die squared dz squared. Here, ds squared represents the squared spacetime interval, dt is the infinitesimal time interval, and dx, die, and dz are the infinitesimal spatial intervals in the x, y, and z directions, respectively. The minus sign in front of the spatial intervals is a result of the spacetime metric signature, which is plus in the standard convention. The Minkowski metric allows us to calculate the invariant spacetime interval between 2 events, which is a quantity that remains the same for all observers in different frames of reference. Events with a spacetime interval of ds squared greater than 0 are said to be space-like separated and cannot influence each other causally. Events with ds squared less than 0 are time-like separated and can be causally connected, while events with ds squared equals 0 are light-like separated and are related to the propagation of light or other massless particles. Minkowski space is a fundamental concept in special relativity and forms the basis for many calculations and theories in modern physics, including relativistic mechanics, electromagnetism, and Einstein's theory of general relativity. It allows for the formulation of physical laws that are invariant under Lorentz transformations, which describe how measurements of time and space change for observers moving relative to each other at constant velocities.